Okay, folks, I guess we should, since it is 6 and um, we should get going and kind of see what questions you have, what uh, things are kind of going on. Uh, I know that you had, last couple of weeks have been kind of crazy for me. So I have not been uh, here at home very much to do that. I've been uh, on the road with some family things to deal with. This seems to be a extraordinarily uh, difficult time for a lot of people, and as the quote unquote patriarch, I guess I'm supposed to bail everybody out. But anyhow, uh, the what I wanted to do this evening, one is to talk about the things that I have put up and opened up on As You Learn. Uh, you'll find that I've done a video demo introduction and then a video demo of analysis of variance and some of the other techniques, correlation, regression, and have not gotten into anything beyond that point yet. I'm getting ready to open that up, but over the next about 10 days. Next Wednesday, I will not be able to meet. I will have a help session on Tuesday, same time, same place. If you want to come to that, you don't, obviously, you're not required to do anything there. Anything that you need to know will be up online and probably in a video online. And the one thing I opened up today when I got back online was the answer key, the answer sheet for the first evaluation, and a video that has me kind of walking through that first evaluation real quickly and kind of laying out what I was hoping that you would find and what I was hoping you would see. So over the next day or so, day or two or three, I will also be going into your individual responses and if there's anything there that differs from what I may have covered on the video or what I may have had on the answer sheet, I'll make some comments. If you are pretty close but didn't quite get the right answer, but you were headed in the right direction, I don't know that that's an issue. You'll have a couple more, at least one more full chance to go through that same content again. If you are way off base, then maybe you and I need to schedule a one-on-one Zoom. I will be right where I'm at right now for the next about 3 weeks, with the exception of next Wednesday, Thursday, and Friday. I will be on the road Wednesday, Thursday, and Friday at some memorial services, and I don't, so I won't be checking anything then. What I would like to know is how you felt about the first evaluation. Too easy, too hard, too whatever. I try to keep those things very straightforward and okay, well, here's an answer to a question. Here's a question, answer this question. And in these evaluations, I'll give you, the hint thing. Okay, well, the hint is, it's independent T, or hint is whatever. On the final, you won't necessarily get that unless it's something that we haven't you haven't had a chance to work on in one of these earlier assessments. We'll talk about the next assessment coming up in just a minute, because it's actually up, and you can, it's a little bit different than this first one, in that there's a lot of, well, I'll talk about now, there's a lot of examples of techniques that I go through, and then there is a question at the end that asks you to answer that question related to that technique. In other words, you know, run some data and generate output and answer the question based on your output. And so there's I think 6 of those, because I've separated them out by technique, because sometimes that helps to look at just the one thing, just the one thing, so you can see sort of the eccentricities of a particular technique, or the points in which it's used. So there are actually 6 of those, I believe, and you have a place to upload. I think up to 8 or 10 files. You'll only need 6, and so you'll upload each one of those as a separate entity. And so there'll be like an upload for descriptives, an upload for t-test, an upload for ANOVA, an upload for regression or correlation. And so you will go through those, kind of walk through the scenario that I laid out. Then you can answer the question at the end, and once you've done that, you just print that off and incorporate the table that you used, and post it up in a submission link. And those are all due by a week from this Friday, I believe. Next Friday, 2 weeks, yeah. They're all due next Friday. And so you can go through those pretty quickly, I think. I don't think there's anything much there to kind of bother you or concern you. The next pieces the next pieces that we're adding are the ANOVA and correlation. And there are a couple of videos up. ANOVA and correlation are kind of included in one video that I did, which I lay out the kind of the rationale for it, the logic, how you lay it out, how you interpret it, things like that, both for ANOVA, correlation, and simple regression. And so, I'm not going to necessarily go through that this evening. I don't think I need to repeat that. But if we do, if you do have questions or whatever, be sure to get in touch with me, or come to the little help session I'll have next Tuesday at 6 o'clock, not Wednesday, Tuesday. And we'll kind of deal with those questions, and then you'll still have 2 or 3 days to get those pieces of work up.
I had a question for you on this week's files. I saw that you had a JASP file for a granularity example, but didn't see anything on that in the videos.
I'm going to do a video on that. I haven't done it yet, but we'll. Okay. I went ahead and left the data set up there. It's one of those. We'll give you a quick sort of tease to it. Think of something like age. If you collected data on age, and you collected people's actual age, then you have what's called a much more granular type of data than if you collected their age in terms of brackets. Like 1 to 18 and 19 to 37, and then 38. If you collected it in brackets, because you're only getting numbers like 1, 2, 3 or 1, 2, 3, 4, that has less granularity to it. And kind of the rule of thumb in statistical analysis is that you want to retain all of the granularity you can, because then you retain all the variability you can. But sometimes that's misleading, and sometimes more variability is not a good thing, because it doesn't really it's very situational. And so this little demo is just designed to show you the difference between different levels of granularity in terms of data, and how you can get different outcomes in terms of significance, depending on how much granularity you have. And there's lots of ways to create it. If for example, the 4-level Likert scale, going from strongly agree, or we'll do it the other way, strongly disagree, disagree, agree, strongly agree, has less granularity than strongly disagree, somewhat disagree, or excuse me, disagree, somewhat disagree, somewhat agree, agree, strongly agree, because one of them has 4 levels and the other one has 6 levels, and the one with 6 levels has more granularity in it. So that's the concept of granularity. But I'll work through that example in a video. Probably won't be tomorrow or this evening. It might be Friday before I get that done. But it's on my list. So yeah. Go ahead.
I was just saying, appreciate that. That sounds good.
Yeah. And there are some other things like confidence intervals and things like that we will I'll do some examples on. And in the last section, there are some other things like propensity matching, and different things that you will see in the medical literature that's a little bit different than you might see in the other social science literature. And so we'll talk through some of those things, because it's important to understand that the medical literature uses a whole lot more odds and likelihoods and things like that than does the traditional social science literature or science literature. And so I know that medical professionals like to talk in probabilities, and you got a 40% chance or 60% chance or whatever. And so we'll look at how those sort of terms are used in medical literature. But once again, that's a couple of weeks down the road. But I will get examples up of all of those things before we get too much further down the road. Other particular questions about the parts that I've just opened up? If you haven't had a chance to look at them, I don't know. Yeah, but look at the videos and look at the particularly the ones on ANOVA and correlation and regression, and then kind of look at the examples, how they play out. If you have questions, shoot them to me, or come next Tuesday, not Wednesday, Tuesday at 6 o'clock, and I'll be here with another help session.
Okay, sounds good. And so the analysis that we did, I know you said you don't really believe in grades. If there's something, like you mentioned, if we're way off base, or if there's something that, you want us to redo, we'll know that. How is there going to be a section in that near
you will hear from me if there's anything that I think you need to redo, or maybe something you need to go back and review.
Okay.
If you don't hear from me, you have the answer set, and you have the video where I go through the answer set and all that. So you should be fine. And in terms of grade, it's a credit thing. It's a formative assessment. So if obviously I would hope there'll be, if you're still struggling a little bit with some of the general concept stuff, I would hope that that clears itself up as we go forward. If we do the next little bit that's due next Friday, and you're still having some, fairly bad use of words, significant issues with a particular concept or a particular approach to things, then maybe we need to schedule a one-on-one, and I'll commit as much time to it as you need to see if we can kind of work you through that or walk you through that.
Okay, great.
At this point, you're either getting it to the point that it's almost seems a bit simple to you, or you're still struggling with one or two little concepts or one or two little things, or you haven't gotten into JASP enough to feel very comfortable with that. And so whatever the issue is, we'll kind of work through that and figure it out. As I said, they wouldn't, this isn't brain science, people. They wouldn't let me teach it if it were more difficult.
Dr. Bowe,
Yeah.
I have a question. You keep referring to next Friday. Next Friday's the 17th. And I know you've written out here it's the 19th.
No, Sunday, that's fine.
Okay. I just want to clarify and make sure that I wasn't missing.
No, I'll go back and fix that. I think it's right on As You Learn. Does it say the 19th on there? Well, it's the 19th. Yeah, 7 and 9, they kind of look alike to an old guy. You get a little crook on that thing there, it kind of looks the same. You've seen where somebody will do a 7 and put a line across it? Yeah, well, that's an old guy shorthand for that's not really a 9. It's a 7, okay? Or a 1 with a head on it. It's really a 7. So, yeah. But this is the 19th, so I'm sorry. I get there. Any other? How about tell me how you felt, experience-wise about the first, this first little evaluation. Did you find it, pretty straightforward, pretty simple to deal with, and kind of roared right through it?
I appreciated that it was very straightforward and it didn't feel like you were trying to trick us or anything like that. I appreciated the straightforwardness of it.
Yeah, I never have seen the logic in doing that. I know a lot of professors play the little guess what I'm thinking game, but I simply see no need to do that. I don't see any rationale to do that at all. I mean, you're taking a class because you want to learn something, and if you want to learn something, then I need to create an environment where you got a chance to learn something. So
Well, thank you.
Yeah, glad to do it. Other questions, for the evening? I'm not gonna do any, I'm not gonna add anything tonight because I've got the videos up and I've got the examples up and all that. So I'm, this really is just how are we doing? You got any particular questions or any things that we need to clear up? And if not, I won't waste your time. And if you told somebody you will be in class for an hour and a half, take advantage. Since they'd already planned for you not to, So if somebody else is cooking supper or somebody else is taking the kids someplace or whatever, let them. Yeah. It's a big world.
Dr. Bolt, when I looked at the postings from last week, I only saw one video that was the introduction to ANOVA and regression. Did you say there was a second video that I?
Yeah. Where did I put those things? Oh, yeah. There's one more I have to post because it's actually a YouTube from another class. So I've got to go and edit off the end of it. I didn't. Yeah, that's what I was talking about. So I'll put that one up too.
Okay, thank you.
I'm sorry. Yeah, right there it is on my sheet of things to get done, and it obviously didn't happen today. I think I got caught up in trying to figure out how to edit more easily than YouTube, and discovered amazingly that Windows 10 has an edit function built into it, and a screen recording function built into it, because it has support for Xbox.
Oh, that's interesting.
And if you ever want to just record the screen, or interactions on the screen or whatever as you go through something, or take snaps of the screen, and you don't want to get into all the convoluted stuff and all, it's what is it? It's Windows button G, Windows G. And then there's a little menu that pops up, a little widget that pops up, and you just say, you select capture, and you get a little capture menu, and you can record whatever's on the screen. And I guess it was because all those gamers wanted to remember their last glory, and so they wanted to record the last game in which they, killed 10,000 aardvark warriors or some, whatever it is they do, some of those games. But yeah, I'll get that up. It'll be up. In fact, it'll probably be up here in maybe an hour and a half. Yeah.
Dr. Bold, I had a question about that video when you were talking about regression.
Yeah.
And you were using that formula of the y equals mx plus b.
Mm-hmm.
How did you know which variable you were going to use for y and which one you were going to use for x?
There's a couple of things there. One, generally, regression is a predictive thing. It's not a causal thing, so we're not looking at causation, but we are trying to predict, if we know one thing, can we predict what another thing will be? And so typically you have in mind what's going to be the sort of the quasi independent variable, which is the, what do I know? And the quasi-dependent variable is, what do I want to predict? And so, for example, we at one time we tried to make the case, we never could make it because it wasn't there, that you could use GRE scores to predict graduate GPA. And so in that instance, the GRE score would be the X, and the GPA, predicted GPA, would be the unknown, or would be the Y. So the Y is kind of the unknown piece that you're trying to predict.
So you would know a value for the other variable then.
Yeah, you would know the X, and you're trying to predict what the Y would be.
Okay.
Yeah, see, Y is really the unknown, and the only way that you can arrive at that sort of notion is if you have a previous data set of X and Y's.
Mm-hmm.
And if you look at the previous data set of X and Y's, that's what regression looks at. And it spins out a function or a formula in the style of the Y is equal to mx plus b, where Y is the unknown, X is the known, M is the slope, and B is the intercept point on the Y-axis. And so it really is, and I don't get into this much in there, but it really is kind of the grandfather and the basic formula that you use to prove things like ANOVA and a lot of the modeling stuff and all like that, because it is the foundation of what's called the general linear model family, which includes t-tests and ANOVAs and different modeling techniques and things like that. And regression is the foundation of all that. But it's also, it's just there. It's not a, you don't have to, you make a logical leap in that you've got these dots and you create a line. Well, the logical leap is if I've got a line, then I know what a formula for a line looks like. And if I know the slope, the correlation value, the R, I know what the slope is, and I can calculate, so it really is the cornerstone of a whole family of analysis techniques, very large family. And that's why regression is so important. But yeah, the Y is always the unknown. The X is what you know. The M is the slope, which the formula will give you, or which the technique will give you. And then the B is the intercept, which is also the technique will also give you that. So.
Okay. And then if you have a problem, you're trying to decide whether to do the ANOVA, which I know has to be done with more than 2 groups, versus the regression. How would I know which direction I want to go in? Which technique I would want to use?
Yeah, that's pretty simple. The ANOVA will always have a continuous dependent variable. It'll be a score or an interval variable.
Okay.
And it will have a categorical variable. And the categorical variable defines the groups. And the continuous variable or interval variable, it creates the variability that you're actually trying to parcel out in different ways. And so in ANOVA, you will always have a categorical variable, at least one, and the dependent variable is always a continuous or interval variable. For regression, you're going to have 2 continuous variables. They will both be continuous, just like correlation. Correlation, they'll both be continuous variables. You would never do correlation when you have categorical variables. You would never do simple regression when you have any sort of categorical variable you're working with. Now, there are techniques that we're going to talk about, the very next thing we're going to get into after this next week, that deal with looking at relationships between categorical variables and ways of using categorical variables to predict outcomes of other categorical variables, a different kind of regression. And correlation uses continuous variables. For categorical variables, the analogous technique for categorical variables is what we call chi-square. And so the next thing we will be talking about is chi-square and logistic regression. And those are the ones, they have nothing but categorical. Correlation and regression have nothing but continuous.
Okay. Nothing but continuous. Okay.
Yeah, I started a little chart of that, I think on last week's video maybe, where I was talking about the different techniques we had dealt with up to that point, and I think I ended that at t-test. We'll extend that chart as we get into the next sort of group of stuff. Yeah.
Dr. Bolt.
Yo.
I noticed the last time before we did the other evaluation, you posted the video that kind of walked us through like examples. Will you post another video of examples and like a walkthrough of this evaluation or no?
Yeah, no. I think the examples that once you get into it, all right, when you start popping open those files, you will see, examples with, screenshots, albeit screenshots from an earlier version of JAS, but I mean, there are, not a lot of difference in what's up there and what you'll see in front of you. And then you'll see what information I used to answer the question I was posing, for that example. And then there will be at the bottom of that sheet with the example will be a question for you to answer. And so you can simply follow the same sort of, you know, technique that I use, the same sort of steps and structure that I use to answer, you know, the example in getting at your answers. And I did not do videos of each one of those. And it just, I'm trying to kind of mix things here. I'm trying to kind of, you know, after walking you through the first one with a video, the next one, you know, we'll just do examples and we'll kind of move in that direction so that, you know, you feel a little bit more comfortable each time about making kind of your own decisions. I mean, that's my miserable logic for that, but hopefully it works.
Okay, thank you.
But as I said earlier, if we need to sit down and we need to, you know, do a live example, or if I get, you know, 10 people wanting to know, I still can't get this, can you please, you know, do an example? I'll do a video for it. I mean, that's fine. You know, I've got all kinds of equipment here. I can do pretty much what I want to with. And so you need to, you know, you just need to let me know what it is that you're not seeing or you're not getting, you know, a grasp on. Other stuff. Now I'm in no hurry. I got no place to go. It's too hot to walk. My Apple Watch is screaming at me that I haven't walked enough today, and it's too hot. I can't walk anymore today.
I came in, Dr. Bolt, just a few minutes after the class started, and when we have these examples that you were talking about, you said that we would post each one on an individual like Word document, and we can submit 5 or 6 different ones.
Yeah, use the same link, and I think you have space in there for 8 or 10, but you will only need 6. So, you know. And feel free to post all 6 at the last minute if you want, or feel free to post them as you go along. That's fine. Nothing else?
No, I think that's it.
Well, feel free. I mean, as I say, if you have questions that come up later, or you know, you kind of start playing with these things and you realize you're having some issues with one of them or a couple of techniques or something like that, just give me a yell and I'll see what I can do about that. But at the same time, we can also you know, as I said, I'll be available next Tuesday night at 6. Not Wednesday, but Tuesday. And I'll be online here. So if you have questions and you show up, great. If not, then, you know, I have plenty to do, plenty to read.
I did have one question about the examples that you had on the video.
Mm-hmm.
I think it's, I'm looking, I had printed off what I could. I think it was in the regression.
Mm-hmm.
I think it was.
Okay.
In the printout or in the coefficient chart that you get, it comes up with like an H0 intercept and an H1 intercept within the GPA listed because of the type of example you put in. And how do we know which one is used in the formula? Is the one that is termed intercept become equivalent to the B when you're using that Y equals MX plus B? Does that make sense?
Yeah. you're always testing the H0.
Okay.
Yeah, you're always testing the H0. That's shorthand for null hypothesis.
Mm-hmm.
You know, the basic statistical technique we're kind of playing with right now is called the NHST, null hypothesis statistical test. And ANOVAs and you know, testing for significance on correlations and things like that, and testing for significance on t-test and all like that, or testing for significant differences on individuals in a normal distribution. Those are all called null hypothesis statistical tests, NHSTs. I know it sounds bad when you say it that way, but anyhow, what they're designed to do is to say, okay, because as a researcher, you always have a bias as to what you think is going on. I mean, you think there's an effect caused by something when you get into the research, or otherwise you wouldn't bother to do the research. I mean, you have a hypothesis as to what the outcome might be. Well, that hypothesis as to what you think the outcome might be is the H1, or the research hypothesis. But because you have a bias, and to work against bias, we want to set the bar as high as we can. So what we end up testing is a hypothesis that says there is not a relationship here, or there is not a difference here, or there is not, and that's the null hypothesis. That's actually what you're testing. And you know, it becomes easier to accept a hypothesis, the null hypothesis, than it is to reject it. There's a little bit of bias, you know, it's easier to accept it than to reject it. And so you're always testing that null hypothesis, that H0. And so that's the value you're always using. What's the value for the null? Hopefully I used the right value there.
Well, it was, what ended up happening is you ended up having the ANOVA chart printout, and then you had the coefficient chart. And the null intercept was 74.077. Then you had the H1 intercept, which was 58.594, and the GPA was listed as 5.555. And you used the 5.555 and represented that as M in that Y equals MX plus B. And then the 58.594 you used as the B intercept.
Well, let me jump over here. Where is that at? Which example is that? That's the
That was the one that you did for the linear regression.
okay. Simple. Is this the correlation and regression class demo thing?
I think so. It was involving the GPA and the post test.
Okay, let me pop that piece of thing up in JASP.
And I guess I'm confused as what significance is the correlation, the Pearson's correlation, when you're looking at the linear regression? Do you use that at all?
Not at that point, no.
Okay.
Yeah, it uses the correlation coefficient as a way of calculation to find the slope.
Oh, okay.
Yeah, so what regression does is it automatically runs a correlation because it needs that value to run the slope, to figure out what the slope is. All right. Now, which particular analysis was that? GPA and?
GPA and post test.
All right, GPA and host.
Is the example right after you did the ANOVA and the post hoc tests.
Yeah.
And you started with a correlation, and then we had a linear regression where it showed another ANOVA with it, and then the coefficient chart at the bottom.
All right. Trying to. Let me see what I got here.
You need to show that there's that Pearson correlation came out with a value of less than 0.05. So you said it was a significant correlation. Do you need to produce that first before you decide to go on and do a linear regression on it?
Well, you don't have to, because I can't run that right now. I don't have that in front of me, so I'm not sure which one you're working with. But
Okay.
the you don't have to, because if you do a regression and you have two things that are not correlated, you won't have a significant model.
Okay.
And so the ANOVA that's used to determine significance there in regression would not be significant.
Okay. So you look at the p-value in the ANOVA, but not the p-value that's in the Pearson's correlations to determine whether or not it's significant. It actually ended up being the same.
Yeah, it typically is. It would be.
Oh, okay.
It's the same. But what you want to know, because what you generate from correlation is an R value, and the R value basically gives you the slope of the line, the direction of the line.
Right.
And the more the R value is closer to 1 or -1 tells you how close that line is to being at 90 degrees or 0 degrees.
Mm-hmm.
Or actually 45 degrees and 45 the other way. But because you never go beyond 1, you never get a value beyond 1, so you don't go all the way vertical and always horizontal. But the regression technique creates a function, this formula is actually a function. And that function has to be measured by something that would allow you to look at different outcomes, not just one outcome, but different outcomes. And that function tells you how tight that. See, the line is actually a cluster. The line is actually a cluster of dots on a Cartesian sort of interface.
Mm-hmm.
So it's actually a series of dots, X and Y dots. And so that function determines a line, but that line in and of itself can't tell you much, because you don't know how far the dots are away from the line.
Mm-hmm.
See, if the dots are clustered close to the line, then that's more likely to be a significant function. If the dots are a little bit further away from the line, then it's not going to be a significant function. And same thing with correlation. I mean, if the dots are close to the line, correlation line, it'll be significant. If the dots are further away, it typically won't be. And the only way that you can figure out whether it's significant or not, and how far away is too far, it runs an ANOVA technique, and it looks at the dots on one side of the line as a group and the dots on the other side of the line as a group, and treats them as if they're categorical, and then sees how well they predict the outcome that function would generate. And so the ANOVA tells you whether regression is significant, but also if the correlation is significant, the ANOVA will be significant. If you had it with, if you did what the ANOVA did and said, okay, there are two groups here, and ran a t-test on it, it would be significant too.
Mm-hmm.
And so all those techniques would find the same thing, but the way in which regression finds it is different. In that it actually runs an ANOVA to see how far, and I'm taking all kinds of liberties here. It actually runs an ANOVA to see how far those dots are clustered away from the line, as opposed to one that's where they're clustered close to the line. So the ANOVA tells you if regression is significant or not. The R value for correlation tells you whether the, once that's interpreted in terms of the N's a big deal in correlation. And so if you have a big number of N, you have a big N, then the R value doesn't have to be very big to be significant. If you have a small N, it takes a really big R to be significant. So, there's some quirks in those things that you really have to kind of work through. We're going to talk about correlation a little bit more as we kind of go forth just a little bit. I didn't want to bring it into this mix here quite yet.
Okay.
But if you want to talk about this some more, give me a yell. I'll be glad. Other stuff, guys? It seems the herd is thinning here, so I'm assuming that they didn't have any questions either. Okay, well, I will, as I said, I'll be in the help session next Tuesday. Remember, Tuesday, not Wednesday.
I couldn't hear what you said.
Oh, shut up. It thought I said Siri. I'm sorry. Sometimes there's too much technology in the room, and it gets a little wonky. Yeah, and I'll be in the room on Tuesday. If you have any individual questions, kind of no matter when it is, shoot me an email, and if we can Zoom, we'll Zoom. If not, I'll try to respond in the email. Yeah, we'll get you there, get you through it. See any problems, any wrong dates, or any, the value looks a little quirky to you or something like that, let me know. I may not have copied all the examples exactly perfectly. I find that I'm doing a little bit more of that these days. But all right, folks, then I will see a few of you next week, probably. If not, I'll see you in a couple of weeks, and we'll be moving right along. We only got,
Thank you.
what, 4 more weeks?
Yeah, going by fast.
Yeah, okay.